Loopmaster Europe was established in January 2005. The directors of Loopmaster are from a drilling background, 30 years of drilling background, following grandfather and father into the industry. So that's where it all began, really. We're actually based right in the centre of the UK, in Nuneaton in Warwickshire, which is good for links all over the UK. We are starting to work more and more, though, in other parts of the world, quite excitingly, in India, parts of Europe and Australia. Our main areas of business are the larger commercial sector, social domestic housing, that type of thing. We concentrate on the design element of ground source heat pumps, because that's really what's required to make a ground source heat pump a sustainable and efficient system. At Loopmaster Europe, we have the only qualified geo-exchange designers in the UK at the moment, and we just want to ensure that people understand that design is critical for the success of a ground source heat pump system. As an example of some of the clients we work for, one of our biggest clients is Land Securities. We're currently doing our 4th project with Land Securities. It's a very large open loop scheme down on Oxford Street in London, very prestigious project. We're very pleased to be working with Land Securities. And another example is a hospital that we're doing at the moment over in Cambridge, which is a very, very large closed loop system which commands 170 boreholes, 152 metres deep, probably one of the largest closed loop schemes in the UK. One of the things that sets Loopmaster apart is the fact that we are totally transparent with our reporting and design issues. We have employees who cover a range of spectrums, hydrogeologists, architects, drilling engineers, so I think we cover the whole spectrum really for the installation of a ground source heat pump system, and we'll demonstrate that it's going to be sustainable and efficient.
My role is a design manager at Loopmaster Europe, and my responsibilities include communication with main contractors. Methods that we use to do that are 2D and 3D CAD simulations. So we can, for example, accurately communicate plant room layouts as they're required. The engineers can actually walk through and around those plant rooms and understand how components will actually merge and unite together. And also in terms of industry standard communication, using AutoCAD and other packages, we communicate technical information for the manufacture and production of those kind of environments.
My role within the company is, as the senior hydrogeologist, is to investigate the geological conditions at a site, see if there are any showstoppers. An example of the showstoppers would be if there is no reliable source of groundwater, or whether the groundwater quality was not sufficient for the purposes of the heat pump. The way that we do this is to conduct a feasibility study. We would look at the geological conditions at the site and the hydrogeological conditions at the site from existing records that are available in the area from the Environment Agency and various other sources. The modelling that we undertake will inform us whether the system is sustainable. It will give us detailed design information and also satisfy the regulatory requirements from the Environment Agency.
Some of the 3D CAD modelling that we do is kind of up-to-date modern technology. It allows the engineering to be fully resolved, so there are very few surprises when we actually turn up on site. The relationships of equipment can be fully explored and communicated with 100% accuracy. And in a world where time means money, we can improve the costs and the quality of those installations by communicating information accurately and confidently.